Hi everyone, I'm Abhi Das from Google Cloud, where I work on strategic partnerships across DevTools and GenAI. Thank you to the Sonar team for having me here today. I want to talk about something every engineering leader today is grappling right now. We have given developers a rocket ship, but we forgot to upgrade the runway. So let's dive right into it. Just to set the stage, we're living through the fastest adoption of developer tool category in the history of software. About 84% developers are now using AI coding tools weekly. 90% of engineering teams have AI somewhere in their workflow. The numbers are staggering. And look at this chart. This is from pull flow analysis of over 40 million pull requests. In February 2024, just 1% of PR involved AI agent. Today, that number is nearly 15%, and this is the data from last November, so less than a year. One in every seven pull requests now has AI agent participating. And that's a hockey stick I've never seen. At Google, we have built an entire ecosystem of AI-powered development. Gemini CLI, which is an open source, a million token context window with over 400 extensions from partners like Sonar, Harness, Stripe, you name it. Second is anti-gravity, our first agent AI IDE where autonomous agents can plan, execute, and validate code across your entire project. Third is Jules, an asynchronous coding agent that handles tasks in the background. And finally, Gemini Code Assist, which is an in-IDE intelligence. Vibe coding is not a trend, it's a tectonic shift. So the question is no longer, should I adopt AI coding tools? It's, are we ready for what's happening next? So what does this revolution actually look like in your code base? The median pull request sizes are up 33% in less than a year. Lines of code per developer has increased 76%. And Google's own Dora report found about 154% increase in PR size. And hence, here's the critical part. About 91% increase in code review time as a result of all this. So developers are now producing almost 8,000 lines of code each. Medium-sized teams are pushing 13,000 lines of code per developer. So that speed feels like productivity. But let me ask you, who is reviewing all this? Because human didn't in the loop didn't get 76% faster overnight, or we haven't hired 76% more developer overnight. So here's where the story gets a little uncomfortable. METR is an independent research organization who ran a rigorous randomized controlled trial with experienced open source developers. They found that when using AI tools, developers were actually 19% slower, not faster. And here's the kicker. The same developer estimated they were 20% faster. So there is 39% of perception gap between how fast developers think that they are with AI and how fast they actually are. So what's eating up that time? 66% of developers told Stack Overflow that their number one frustration with AI solution is that the code is almost right, but not quite. 2/3 are spending more time debugging, and more than 2/3 are spending more time fixing security issues. As one developer put it in MIT Tech Review, you remember the jackpots, but you don't remember sitting there and plugging tokens into the slot machine for hours. And that's the velocity trap. Think of this as an iceberg. Above the waterline, you have 76% increase in code output, and it looks amazing in your dashboard. But below the waterline, it's a hidden mountain of technical debt that's accumulating faster than ever. GitClear analyzed about 211 million lines of code and found an eightfold increase in duplicated code blocks. Code refactoring has declined by 60%. For the first time in history, software development, developers are pasting code more often than they're refactoring it. Think about it. And lastly, CodeRabbit analyzed about 470 real-world pull requests and found AI-generated PRs have 1.7 times more issues across every category. That includes logic errors, maintainability, security, and performance. Incident per pull request are up by 23%. That is the AI code tsunami. More code is flowing in, but the quality infrastructure hasn't scaled with it. Now let's talk about what's keeping CISOs up at night. Veracode tested about 100 large language models on 80 real-world coding tasks. 45% of the AI-generated code failed security test. And in Java, that failure rate was almost 72%. The specific risks are alarming. About 86% of the code samples failed to defend against cross-site scripting. 88% were vulnerable for log injection. And the most concerning finding is security performance did not improve with larger and more sophisticated models. The models got better at writing functional code, but not secure code. It gets worse. Endor Lab found 80% of AI-suggested dependencies contain known security issues. And researchers have discovered a new type of attack called slop squatting, where AI models hallucinate package names that don't exist in 20% of the cases. Attackers registered those phantom package names with malicious code. So how do we escape this velocity trap? The answer is not to slow down. I don't think anything is going to slow down. The answer is not to hire more reviewers. The answer is to shift from manual oversight to automated code assurance. As Tariq Shaukat, Sonar CEO, told McKinsey a few months back, we have moved beyond code generation being the bottleneck. The challenge now is clarity and trust. And he's right. The bottleneck has moved from writing code to verifying code. And this is where companies like Sonar become essential infrastructure, not just nice to have, but the verification layer that makes 10x velocity that is sustainable. The approach is threefold. One, automatically detect AI-generated code. Two, analyze it against quality and security gates that are calibrated for the AI output. And number three, remediate issues before they ever reach production. Now let me show you what it looks like in practice with Google Developer Tools and SonarQube working together. First, some context around Sonar's own survey. Over 1,100 enterprise developer participated in the survey. 96% do not fully trust AI-generated code, but only 48% always verify before committing. Teams are spending a quarter of their week, a full day in a week, just checking and fixing AI output. That's the verification gap. SonarQube has built what I think is one of the most comprehensive AI code assurance platform in the industry. It starts with automatic detection. SonarQube now identify when AI tools are generating code in your repos and automatically apply stricter quality gates. SonarQube's MCP server gives you over 25 tools to plug into Google's developer tools, directly into developer tools. And through Gemini CLI, anti-gravity, code assist, and other tools. Your AI agent can analyze code snippet against SonarQube's rules in real time, search existing issues, and check dependency risk, all without leaving terminal or the IDE, maintaining developer flow state. And it gets even more powerful with anti-gravity, our agent-first IDE. When anti-gravity's autonomous agents are planning, writing, executing code, SonarQube quality gates are embedded in the loop. The agent doesn't just generate code, it validates it against quality standards autonomously. At Google, we have integrated Sonar across our dev toolchain, including Gemini CLI, anti-gravity, and other tools. Whether your developer is in a terminal, or orchestrating agent or working with their IDE. Sonar's quality gates are there giving real-time feedback as they code, not hour later when during the review time. Now let me show you a quick demo of how Gemini CLI interacts with SonarQube. Just a high rundown is um, you download Gemini CLI if that's the CLI you want to use. You download the SonarQube extension. You set some environment variables. You launch Gemini and you connect the MCP server, and you basically talk through your CLI directly to Sonar instance and figure out issues and remediate issues from the CLI directly. So quickly, let me switch tab and go here. So that's our Gemini CLI main homepage. You can go ahead and download the CLI. All the instructions are there. I've already downloaded it, so I'm going to skip this path. Let me go to the extension gallery, and we have about 414 extensions already available in the marketplace. Now let me search for SonarQube MCP server, and the installation instruction is here, and we have a GitHub page as well. Just switching back to the GitHub page, I've already installed it and basically run that command and set up the token URL and org from Sonar's UI, and then you interact with the terminal. Let me start sharing my terminal here. Okay, so this is my Gemini CLI instance that I've initiated in my CLI environment. So first, I'm going to just ask a few questions. I already have this pre-populated because I was testing right before this. So I can ask Gemini CLI, hey, show me all my SonarQube projects. And it's going to do it's going to call the MCP server, analyze my projects, and sort of give me the list of projects at the beginning. It's going to take just a minute. I can see that it's already pulling in those project names. So I have 3 projects in my repo that I will give access to Sonar Scan that already listing it. Also, one thing I forgot is you can also validate your MCP server installation via MCP command and see some of the MCP server that got connected. I think SonarQube is showing disconnected for some reason. But let me go back and get some other commands here. If I type find all my blockers or issues in my code base, it should be able to call the Sonar's MCP server, find all the blocker issues, and list it here. Okay, so it actually gets me that what is the one blocker issue I have for my Mindwave project. And here it also suggests that, hey, if I would like the CLI to actually fix this issue and check in and then trigger SonarQube back as well. So I can also ask, what are the quality gate status for my project Mindwave here? And the last thing I will do, similar command here. This should pull in fast. Okay, so it gave me failing conditions, reliability rating, duplicate line density, security rating, maintainability, but currently the status is failed for Mindwave that I can already see from my CLI. I can ask similar, let me just do a quick analysis on code quality from my project using Sonar's MCP server. It should give me a quick analysis of code quality. And as I can see, it's already pulling in the details. Okay, so now I have the issue breakdown. I have 19 bugs, maintainability issues, blocker the different level of security breakdown and key concerns. So I'll stop here in terms of what you can do. There are like multiple other things that's possible through the MCP server. But I think the essence here is, let me switch back to the demo slide here. Coming back to my screen here. The essence really here, what you saw is from the CLI, you can write code. You can call MCP server, Sonar MCP server to analyze that code. You can figure out exactly what are the issues and vulnerabilities that needs to be addressed. You can pick specific vulnerabilities, address that in the CLI, check in the code, re-trigger Sonar, and do the scan again and see if it got addressed, all without leaving the CLI. That's sort of the most important piece here. All right, so the final step here, the final slide. So I'll leave you with this framework. Sonar calls it guide, verify, and solve. And I think it perfectly captures how to escape the velocity trap. Step one is guide. Equip your developers with Google's AI development ecosystem, be it Gemini CLI for the terminal, anti-gravity for agent orchestrated development, code assist in the IDE, Jules for async background task. Don't just stop there. Connect with tools to your quality infrastructure via MCP. So AI has the context about your standards from the start. Second is verify. Deploy AI qualified quality gates. AI generated code needs stricter standards, not just the same ones that you use for human written codes. Auto detect where AI code enter your repo and hold it to a higher standard. And step three is solve. Close the loop with agentic remediation. When quality gate fails, don't just create a ticket and wait for someone to take a look at it in the next sprint. Let the remediation agent fix it autonomously, verify its own fix, and then push it to the PR. The future of software development is not human versus AI. It's guide, verify, solve on repeat at every commit. Google's tool generate, SonarQube verifies, and agent solves. And your developers stay in this flow state. One last thing, everything that I showed you today in Gemini CLI was the same way using the MCP server with anti-gravity and other tools. SonarQube MCP server is your quality layer wherever your developer code, no matter anti-gravity, Gemini CLI, and other tools. Thank you, everyone. The link to everything that I mentioned are on this slide: Gemini CLI, SonarQube MCP server, and that's about it. Enjoy the rest of the Sonar Summit. Thank you.